Today you will be learning about the link between the roots of a polynomial and its coefficients. See if you can find the roots of these quadratics. Pause the PowerPoint here before I reveal the solutions. To the first one we have -3 and -2. The second 5/2 and -3. And the final one -1/2 and 4/3. Now let's take a look to see if we can work out what the relationship is between the quadratic equation and the sum of the roots. So if we work out the values for the sum of the roots first of all, so the first one is -5, the second one is -1/2, and the last one is 5/6. So what is the pattern? What links the -5 to this quadratic, the -1/2 to this, and 5/6 to this one? Can you see that the coefficient of the x term plays a part in the sum? But actually not just the x term, because the coefficient of the second one is 1, and that is relating to the number on top of this fraction. So where is the 2 coming from? Well, that's coming from the x squared coefficient. Let's check on the final one. So we have a -5 here, which is the numerator of the sum. And the 6, well, that's the denominator. But be careful as well, because we're also having to take into account that there are some negatives. So the number from that first one wasn't just 5, it was +5. And notice that the sum is -5. When it was +1 for the second one, it was -1/2. And when it's -5x on the last one, the numerator there, we have 5. Now let's take a look at the relationship between the quadratics and their product of the roots. Multiplying the two roots together, for the first one is 6, the second -15/2, and the final one is -4/6. Now hopefully you can see this a little bit quicker. So 6 here is relating to not only the end value, the end coefficient, but also the coefficient of the x squared term, which we know is 1. And then the second one, -15/2. So we've got the -15 here at the end and the 2 at the beginning. And the final one, -4/6, -4 and 6. So it's always, we are looking for the product of the roots, the final coefficient, and the coefficient of the x squared term. And for the sum of the roots, we are looking at that middle coefficient with the x and the coefficient of the x term. Now let's formalise this and have a look at how this is worked out using algebra. Okay, let's formalise this. Here is the general equation of a quadratic. So this is for your notebooks. And this can be rearranged into this form. So here we've divided through by that leading coefficient of a. And then we can factorise this. So this would be x minus alpha over x minus beta. Now we're going to try and work out what the relationship is between the alpha and the beta and between the coefficients of the quadratic above. So if alpha and beta are the roots, then what we can write is that we have this equation on the left hand side must be equal to this on the right. And so if we expand the right hand side and group together the coefficients, so we have minus alpha and minus beta on the right hand side there, will be equal to b/a from the left hand side. And we have the c/a on the left hand side must be equal to the alpha beta on the right hand side. And so just to summarise here, the sum of the roots, alpha plus beta, will be equal to -b/a. Now that comes from factorising out that negative sign and multiplying the equation through by -1. And the other one there, the product of the roots, so alpha beta, will be equal to c/a. Now we've been given the sum of the roots, alpha plus beta, being equal to 6, and the product of the roots, alpha beta, is equal to 8. Let's use these to work out the values of the following expressions. So for the first one, we have 2 alpha plus 2 beta. If we factorise out the 2 from both parts of that expression, we will be left with alpha plus beta. Now we know the value of alpha plus beta is 6, so this expression must be equal to 12, 2 lots of 6. Question 2. This time we need to see what we can factorise out here, and we have an alpha beta that we can take out, and that leaves us with an alpha plus beta in the brackets. Substituting in the values there, we have 8 multiplied by 6, which gives us 48. The third one, we need to put the fractions over the same denominator. So if we multiply the first fraction by beta and the second fraction by alpha, that will give us alpha plus beta over alpha beta. And then substituting in the values for the sum and the product, we will end up with 6 over 8, and that reduces to 3 over 4. Now notice every time that we're simplifying, we're trying to get into the forms of the 2 things that we were given in the question. So we're looking for finding alpha plus beta or finding alpha beta, and that can then help us work out a value for each of these expressions. Question 4. So we have 2 brackets here, so if we multiply these out, multiply them together, that gives us alpha beta plus beta in a bracket plus 1. Notice that the brackets there, just so it gives you that kind of leading in to say, well, alpha plus beta is equal to 6, and then we can substitute in those values. So we would end up with 8 plus 6 plus 1, which leaves us with 15. Question 5. This is a little bit trickier, and this rule you do need to remember. Now this comes from the fact that if we take alpha plus beta all squared and we multiply this out, this gives us alpha squared plus 2 alpha beta plus beta squared, which is then equal to alpha squared plus beta squared plus 2 alpha beta. Now notice that we have the alpha squared plus beta squared in this expression, which is what we have down here. And so alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. So that is just us rearranging that top expression. Putting the values in gives us an answer of 20. Question 6. Similar to question 3 here, so we're going to multiply the fractions together so they have the same denominator. So the first fraction will be multiplied by beta and the second by alpha. This takes us to alpha squared plus beta squared over alpha beta. Now because we've already worked out the numerator, we can take that from question 5. So that would give us 20 divided by 8, which reduces to 5 over 2. Now you'll want to write this one into your notebooks. Make sure that you have this nice and clear. So alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. You do need to learn that. But now we can also have a look at alpha cubed plus beta cubed. And these help us later on as we're trying to solve some more complicated problems. So if we start with alpha plus beta all cubed and we multiply this out, and the easiest way to do that is using the binomial function or Pascal's triangle 1, 1, 1, 2, 1 to work out the coefficients. Or you can just straightforward multiply those 3 brackets together, but it will be a little bit more lengthy in terms of working out and then simplifying. Now notice that we can group these together. So the idea is that we're trying to get to a form where we have alpha cubed plus beta cubed isolated on its own. So we're going to subtract these 2 terms here. And then we can rewrite this. So if we were to factorise those 2 expression, two parts of that expression there, that would leave us with 3 alpha beta multiplied by alpha plus beta. And this is the second important equation for you to write down. Okay, have a go at completing this table. There is a worksheet that goes alongside this that you should be able to access. If not, ask your teacher for that. Have a go at completing it now. There is a second question on the next slide, so you may wish to have a look at that too, and then we'll go through the answers following those questions. Pause the PowerPoint now and complete this slide. Here is the second question. Have a go at completing this and then move on to the solutions. Here are the solutions. Take a little bit of time to make sure that you have got everything correct. And the final one then. So here are the solutions to the second question. For further practice, turn to page 40 and complete exercise 2C.